Xin chào. Well, that's the way we say hello in Vietnam. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, we are doing binomial theorem. We've already had 2 lectures in which we have discussed the basics of expanding a binomial raised to any natural number power. And now we are doing certain sums. This is the second lecture where we are discussing some sums, right? In the first lecture, we had just the description of what an algebraic expression is, how we expand a binomial which is raised to any natural number by a single sum. Then the next 2 lectures were ones on how we get sums on binomial expansion. So now, children, in this lecture, you will get to see some more sums. Now, the first sum that I have for you people is something like this. So quickly give it a try. I'll give you a few seconds for trial, after which we will be discussing the sum. Okay, children, now let's discuss the sum. Here in the question, you've been given find the value of 99.9 raised to the power 3. I'm sure you are pretty excited to think that this is a sum that we can do very easily by first finding out the square of 99.9 and then again multiplying it with 99.9 to get to the final answer. I'm sure you will get to the correct answer, but not to the correct marks, as the teacher won't be happy with you applying something which you learned in a much junior class. So go ahead with applying the concept of binomial theorem and then expect to get full marks. So next, now, if we are to do this by binomial theorem, the first thing that we're going to do is, if from 100, if we subtract 0.1, then we will get 99.9, and thus this monomial has been converted to a binomial which is raised to the power 3. Now we can write this in terms of powers of 10, as this becomes equal to 10 raised to the power 2, from which you subtract 1 upon 10 and then raise its power to be 3. Next, we will quickly recall the binomial theorem. That is, if we talk about some x plus a which is raised to the power n, then that becomes equal to nc0 x raised to the power the difference of the superfix and the suffix, that is n, multiplied with a raised to the power the number in the suffix, that is 0. To that is added nc1 x raised to the power n minus 1 a raised to the power 1, plus we have nc2 x raised to the power n minus 2 a square, and children, all of that continues up to ncn x raised to the power n minus n, which is 0 times of a raised to the power n, right? So this is how we have the binomial expansion, which now we are going to apply to this binomial. So next, now we talk about expanding this. So this comes to 3, which is the value of nc0, right? Then we have 10 raised to the power 2, which is x raised to the power 3 times of minus 1 upon 10 raised to the power 0, plus we have 3c1 10 raised to the power 2 raised to the power 2 times of minus 1 upon 10 raised to the power 1, plus 3c2 10 raised to the power 2 whole raised to the power 1 times of minus 1 upon 10 whole raised to the power 2, and to that is added 3c3 10 raised to the power 2 whole raised to the power 0 times of minus 1 upon 10 raised to the power 3. So this is the expansion, which now we further require to solve so that we can get to the final answer like a single number. Now, when we talk about the first binomial coefficient, remember it is equal to the last binomial coefficient. So if you talk about 3c0, it is going to be equal to 3c3, and as we've looked up in the past, the value of the first binomial coefficient is equal to the value of the last binomial coefficient, and both of these are equal to 1, right? That we looked up in other cases as well. So do remember this, that we can write the first binomial coefficient to be just 1. So we have 1 which is multiplied with 10 raised to the power 6. Why so? Because if we talk about some a raised to the power m and we raise it to an n power, so that will become equal to a raised to the power m into n, right? So similarly here, children, what we do is we have 2 into 3 which thus becomes equal to 6, and further this is multiplied with 1 again, because any number whose power is 0, right, that becomes equal to 1. So using this rule of indices, now we have just 10 raised to the power 6, which will become the first term. Then we come to the second term, as we find that there is minus raised to the power 1. As such, we will now have a minus outside here, right? And then further we will now talk about 3c1. Now here, children, I like to remind you that if we talk about the second binomial coefficient, or in other words, it is equal to the second last binomial coefficient, that is 3c2. So 3c1 and 3c2 will have the same value. Now coming to the value of this, remember that if you talk about the second binomial coefficient or the second last binomial coefficient, they have the same value, right? And what is their value? Their value is equal to the superfix, right, of both the cases. So the superfix is 6 here, and thus the value of the second or the second last binomial coefficient also comes to 6, right? So this is what we are going to apply in this case as well. So as the superfix is 3 here, so the value of the binomial coefficient will become equal to 3. Further, we have this multiplied with 10 raised to the power 4, as 2 into 2 will become equal to 4 by the application of this rule of indices that we just looked up. Next, now after this, we will further multiply this with 1 upon 10 and simplify in the next step. Then we have 3c2, which becomes equal to 3c1, which is equal to 3, right, to be further multiplied with 10 raised to the power 2 and divided with 1 upon 10 raised to the power 2, because minus 1 into minus 1, that is minus into minus, will become equal to plus, as the whole power is 2 here. Right. Next, now children, after this, now we talk about 3c3, which will become equal to 1 to be multiplied with 10 raised to the power 2 whole raised to the power 0, which will again become equal to 1 to be further multiplied with minus 1 upon 10 raised to the power 3. So we will have 1 upon 10 raised to the power 3, and as minus into minus is minus, so as such the final sign of this is going to become equal to minus. Now we'll further simplify all of this. As such, we have 10 raised to the power 6, that is 1 2 3 4 5 6, right? That is a million, right? And from that you subtract now 10 will get cancelled from the numerator and the denominator, so now you'll be left out with 3000. To that, children, you will add just 3, as 100 from the numerator and from the denominator will get cancelled, and then you have minus 0.001. So for the children, we will add the ones which are positive, and the ones which are negative are to be subtracted, right? So as such, finding out the sum now, what we do is we have 10 raised to the power 6, which is to be added to 3. As such, in the units place we will write 3, and rest we will have all zeros except the first place, which is going to be occupied with 1. So we have 1 2 3 1 2, and now we will write a 3 here, and from this, children, we are going to subtract the sum of 3000 and 0.001. So that is going to become equal to 3000.001. Now, children, our next task is just to subtract. Now we can write here 3 zeros after decimal. Further, 1 and 9 becomes equal to 10. Then we have 1 and 9, which becomes equal to 10. And further, we will again have 1 and 9, which will become equal to 10, right? And then further, next we can write this to be 1 and 2, which becomes equal to 3. Right, and further then we will just write a 0 as it is, a 0 as it is. 3 and 7 will become equal to 10. Then we have 1 and 9, which will become equal to 10, 1 and 9, which will become equal to 10. So as such, this, children, is going to become our final answer, which we require to copy. So it becomes 997,002.999, which is going to become your final answer. That is the cube of 99.9. This was pretty simple, although this was a little long and tedious, but in order to get marks, you will have to do it by this method. So children, just quickly discussing this, we have 99.9 raised to the power 3, which requires to be calculated. So now we have 99.9, which can be written as 100 minus 0.1, right? And the power will remain to be the same. Now we will write 10 and 0.1 as powers of 10. So we have 100, which can be written as 10 raised to the power 2, and shifting a decimal for the second term, we can write it as 1 upon 10. Now this monomial has been converted to a binomial. As for a binomial expansion, we have the binomial theorem, that is NC0 x, that is the first term, raised to the power, the difference of the superfix and the suffix, times of a raised to the power 0, that is the number in the suffix, and so on. We expand up to the last term, which is NCN x raised to the power the difference of the numbers in the superfix and the suffix, times of a raised to the power the number in the suffix, that is n. Now children, our task is to use this binomial theorem for this sum at hand. So now we have 3C0 first term x 10 raised to the power 2 raised to the power 3, right, times of the second term minus 1 upon 10 raised to the power 0, and so on. We can do this up to the last term, which becomes 3C3 10 raised to the power 2, that is x raised to the power the difference of the superfix and the suffix, that is 0, times of the second term, which is minus 1 upon 10 raised to the power number which is there in the suffix, that is 3. Now further children, we will have to expand this, where I reminded you one thing, that if we talk about the first binomial coefficient and the last binomial coefficient, they are both equal and further also equal to 1, right, as we've done in earlier sums. So when we talk about the first binomial coefficient, or if we talk about the last binomial coefficient, remember both of these will become 1. Similarly, when we talk about the second binomial coefficient and the second last binomial coefficient, they are also going to be equal, right? And for that matter, when we talk about the second binomial coefficient, something like a 7C1 or a 13C1, it will just become equal to the number which is there in the superfix, like 3 here. So that's why we have a 3 here, and similarly a 3 here. These are just shortcuts. Otherwise, if you need to calculate, you can even calculate and check. Further, we write the proper powers of these numbers, then write them as proper numbers after simplification. We add the ones which are positive, and we also add the ones which are negative. From the larger number, that is the positive number, we subtract the lesser number, which is the negative number, and then we get the difference, which will become the final answer. So is everybody clear about this? For sure. Mitanshu, Divyansh, very good. Okay children, now after this we will be discussing the next sum, and that goes something like this. Quickly give it a try. I will give you a few seconds for trial, after which we will be discussing the sum. Okay children, now let's discuss the sum. In the question, we've been given the difference of two binomials. Now, to quickly remind you about what the binomial theorem is, if we talk about some x plus a, which is raised to the power n, we have nc0 x raised to the power n, a raised to the power 0, plus we have nc1 x raised to the power n minus 1, a raised to the power 1, and all of this continues up to the last term, which is ncn x raised to the power 0, a raised to the power n. So this is the writing of the formula, which wherever whatever formulae are applicable, make sure to write it in your solution so as to get to full marks, right? Next, now we apply this to the first as well as to the second binomial. Now in the first step, now we will talk about 3c0 root 3 raised to the power 3 root 2 raised to the power 0, and then we have the second term as 3c1 root 3 raised to the power 2 and root 2 raised to the power 1, plus we have 3c2 root 3 raised to the power 1 and root 2 raised to the power 2. Then further we have the last term, which is 3c3 root 3 raised to the power 0 and root 2 raised to the power 3. Right, from that is to be subtracted now the expansion of the second binomial, which can be written as 3c0 root 3 raised to the power 3 times of minus root 2. Remember, we've got to pick up the terms along with their signs, right? Raised to the power 0, and to that is to be added 3c1 root 3 raised to the power 2, and remember minus root 2 raised to the power 1, so that can be written as root 2, and we can put up the minus sign outside. Next, now we have 3c2 root 3 raised to the power 1 minus root 2 whole square, so obviously that will become equal to root 2 square, and minus minus will become equal to plus. As such, we'll put up a plus sign. Then children, we have 3c3 root 3 raised to the power 0 and root 2 raised to the power 3, as it was minus root 2 raised to the power 3, so minus into minus into minus will become equal to minus. Now children, we will try and cancel off those terms which are alike, right, and with opposite signs. So we find that if here we talk about a minus sign, the minus sign is applicable to all of these terms, so we require to put up a bracket here, and thus those which are with opposite signs after the application of the minus sign are going to be cancelled off. So we find that the first term will get cancelled with the first term, right? Then the second term after multiplication of a minus sign will become positive. As such, it is going to be left, right? So as such, now we will have now 2 times of the term which is the second term and the second term of both the series, right? Both of these are going to be added. And similarly children, if suppose we talk about the ones which are positive and negative after the multiplication of the minus sign, again they are going to be added, so both of these terms will also be added. As such, it will be some term x, right, with some term x, both of these getting added will become equal to 2x, right? So that's why we have this 2 which is taken common outside, and inside now we have 3c1, right? We have root 3 which is raised to the power 2 times of root 2 raised to the power 1. To that is to be added 3c3 root 3 raised to the power 0 and root 2 raised to the power 3, right? And now children, we will add both of these to get to our final answer, right? So now children, we know that if we talk about the second binomial coefficient, it comes to just the value of the superfix, that is 3, right? And it will be multiplied with root 3 raised to the power 2, that is 3, and further to be multiplied with root 2. Next, if we talk about the next one, we now have here 3c3. So 3c3 is another such term which will have its binomial coefficient to be known, as it is the last binomial coefficient. So as such, what will happen is we will now have this to be 1. So 1 is going to be multiplied with 3 raised to the power root 3 raised to the power 0, which is 1, and further to be multiplied with root 2 raised to the power 3, as root 2 into root 2 into root 2 can be written as something like this. Root 2 into root 2 children will become equal to 2. As such, this will become equal to 2 root 2, which is the value of root 2 raised to the power 3. So we will have into 2 root 2, right? And further, when we multiply this with 2, we will get to the final answer. So now finally we can write this to be 3 3s are 9. So we have 9 root 2 plus we have 2 root 2. Root 2 can again be taken common outside, so taking it common, now we will have our final answer, which can be written as 2 root 2 times of, we have 9 plus 2. Now 9 plus 2 is 11, so as such 11 into 2 will become equal to 22 root 2, and this children will become the final answer. So I'll just quickly discuss this once more. In the question we've been given here that we have here to evaluate root 3 plus root 2 raised to the power 3 minus root 3 minus root 2 raised to the power 3. So as we know the binomial expansion to be nc0 x raised to the power n times of a raised to the power 0 plus nc1 x raised to the power n minus 1 times of a raised to the power 1, and all of this continues up to the last term, which is ncn x raised to the power 0 times of a raised to the power n. Right, so further applying this binomial theorem to both of these binomials, we now have the expansion of the first one to be 3c0 root 3 raised to the power 3 times of root 2 raised to the power 0, and all of that continues up to the last term, which is 3c3 times of root 3 raised to the power 0 times of root 2 raised to the power 3. Now we talk about the expansion of the second binomial, which becomes equal to 3c0 root 3 raised to the power 3 times of minus root 2 raised to the power 0, right? And then similarly we will now talk about the next term, which will be 3c1 times of root 3 raised to the power difference of 3 and 1, that is 2, times of minus root 2 raised to the power 1. As we have one minus sign, when it gets multiplied with the plus sign outside, it will become equal to minus, right? Similarly, when we talk about the next term, it will be 3c2 root 3 raised to the power 1, that is the difference of 3 and 2, times of minus root 2 raised to the power 2. As minus into minus will become equal to plus, so this plus sign will remain as it is. Next, we talk about the last term, which is 3c3 root 3 raised to the power 0 times of root 2, or rather minus root 2 raised to the power 3. So since we have minus root 2, minus will come 3 times, so minus into minus will become equal to minus. As such, we will have a minus sign outside. Next, children, we get to see that we have certain terms which are exactly the same, that is identical, but are having opposite signs, so they will get cancelled. Like if we talk about this term, that is the first term and the first term of the other series, as both of these share signs, right, which are opposite, so they will get cancelled, right? So we will now have here this term and this term, that is the first terms, getting cancelled, right? And similarly, now if we talk about the second terms will get added, as when minus sign gets multiplied inside, we will have this term and this term added, which are exactly the same, right? And that is why we have 2 times the second term. Then when we talk about the next terms, right, the next terms are one such which will again get cancelled, as we get to see here that we will have one with a plus sign, right, and the other with a minus sign, right? As this minus sign will get multiplied inside, so we will now have here minus, right, 3c2, just like this above term, root 3 raised to the power 1 times of root 2 raised to the power 2. So both of these will cancel each other, right? As such, now minus into minus plus, this term with this term which are identical will be left, that is 3c3 times of root 3 raised to the power 0 times of root 2 raised to the power 3, right? So now, children, as we know that the first binomial coefficient and the last binomial coefficient are exactly the same, and their values are also equal to 1, so that's why we will keep their values to be equal to 1, just like 3c3. And when you talk about the second binomial coefficient, it is equal to the second last binomial coefficient, which is equal to the number in the superfix, that is 3. So that's why we will write it to be 3, right? Or you can even find it out and you will get to 3. Then we have root 3 into root 3, which will become equal to 3 multiplied with root 2, right? Now in the next term we have root 2 cubed, so that will become equal to root 2 into root 2 into root 2. Obviously root 2 into root 2 is 2, so this will become equal to 2 root 2, right? Now, children, out of both of these we can take root 2 common even. So when we take root 2 common outside, we will now have here 2 which gets multiplied with root 2, and 9 and 2 will become equal to 11, right, which are the ones which are left out. So 11 into 2 is 22, so we will have 22 root 2, which, children, is going to become the final answer. So are you children clear about this? For sure? That's good. Now, children, after this we will now be discussing the next sum, which looks something like this. Quickly give it a try. I will give you people some time for trial, after which we'll be discussing the sum. Okay children, discussing the sum now, we have to prove 3 raised to the power 2n plus 2 minus 8 raised to the power 8n minus 9 is divisible by 64. Now in order to prove this children, remember we have the number 64 which can be written as 8 square, and somehow from the first number, right, or the first term, we've got to coin 64. So let's see how we can do it, right? So first what we do is we pick up the first term that we have here, that is 3 raised to the power 2n plus 2. Next what we do is we can write this to be 3 raised to the power 2 times of n plus 1 in the numerator, because in the power, because in the power children we have 2 which is common in this binomial. Further now we can write this as 3 raised to the power 2 whole raised to the power n plus 1, which is just the reverse of the rule of indices that you've learned. That is, if you talk about a raised to the power m whole raised to the power n, then that becomes equal to a raised to the power m into n. So here we are using the reverse of it, that is, we have a raised to the power m into n, and we are writing this as a raised to the power m whole raised to the power n for our benefit. So next now what we do is 3 raised to the power 2 is just like 9, right? Because 3 into 3 will become equal to 9, which is raised to the power n plus 1, right? So next now children, what we can do is, as we've got to bring 64 somehow, which is 8 square, so now we can write this as 1 plus 8, which will become equal to 9 whole raised to the power n plus 1. Now the benefit is somehow we've been able to get to 64, that is 8 square is going to become equal to 64, right? So our task is to get to such a number whose square or cube we have a number here, right? So next now children, what we do is we now talk about the binomial expansion of some x plus a which is raised to n power, and that will become equal to nc0 x raised to the power n a raised to the power 0 plus we have nc1 x raised to the power n minus 1 a raised to the power 1 plus we have nc2 x raised to the power n minus 2 a square, and all of that is going to continue up to the last term, which is ncn x raised to the power 0 a raised to the power n. Now applying this, guys, we now have here n plus 1 c0 1 raised to the power n plus 1 and 8 raised to the power 0, right? Further then we have the second term as n plus 1 c1 1 raised to the power n, and then we have 8 raised to the power 1, and then the next one is n plus 1 c2 1 raised to the power n minus 1 and 8 raised to the power 2, and children, all of that is going to continue up to the last term, which is n plus 1 cn plus 1 multiplied with 1 raised to the power 0, right? That is n plus 1 minus n plus 1, right? And then we have here 8 raised to the power n plus 1, right? Now remember, all of this is equal to 9 raised to the power n plus 1 with which we started, right? So here for the next we can write it equal to 9 raised to the power n plus 1, right? Further what we do is, if say we talk about calculation of all of these terms, we can write this to be equal to now n plus 1 c0, that is the first binomial coefficient, will become equal to 1 multiplied with any power of 1 will again become equal to 1 multiplied with 8 raised to the power 0 will also become equal to 1. Further to that we are going to add now n plus 1 c1. I told you the first binomial coefficient will become equal to the value of the superfix, that is n plus 1. Now this is to be multiplied with 1 raised to the power n, which again is going to become equal to 1 multiplied with 8 raised to the power 1, which will become equal to 8. And then we have the other terms which we need not calculate, so we can just write nc1 c2 right, multiplied with 1 raised to the power n minus 1, that is any power of 1 will become equal to 1, right, and further multiplied with 8 square, right, which becomes equal to 64, right, and then further if you talk about the next one, it will be n plus 1 c3, and then we have this again to be multiplied with 8 raised to the power 3, and all of that continues up to n plus 1 c n plus 1 times of 8 raised to the power n plus 1, right. Now here children, what we can do is we can write this equal to what we have on the right hand side, that is 9 raised to the power n plus 1, right. Now children, in the next step what we do is we can now write this 9 raised to the power n plus 1 again to be getting back from where we derived it, that is 3 raised to the power 2 raised to the power n plus 1, which becomes equal to, now the first term is 1, remember, right, and then we have the next term to be plus 8 times of n plus 1, and to that then we can do what, we can take 8 square to be common outside, and inside then we have n plus 1 c2, then we have n plus 1 c3, which is going to be multiplied with 8, right, and then as 8 square was also there, which has been taken common out, then we have n plus 1 c4, and obviously this will have 8 raised to the power 2 as 2 powers of 8 has been taken out, and further children, the last term is then going to become equal to n plus 1 c n plus 1, and it will have 2 powers of 8 taken out, so it will be 8 raised to the power n minus 1, and that is all that we have. Now what we do here is we can write the left hand side to be again multiplying the value of m and n, that is multiplying 2 with n plus 1, so it is going to become equal to 3 raised to the power 2n plus 2, right, and now we can subtract the first two terms from the right hand side brought over to the left hand side, that is minus 1 and minus times of 8 times of n plus 1, right, and then on the right hand side we are left out with 8 square, which becomes equal to 64 times of all of these, remember, are from the set of natural numbers, so we can consider it to be, say, some p, right, where we will write that p is an element of natural numbers. Now next children, what we do is we go to the next step and we can further simplify the left hand side to be writing this as 3 raised to the power 2n plus 2, right, and then we will have minus 1 minus 8n minus 8, which will become equal to some 64p, as all of these numbers, that is the binomial coefficients multiplied with some powers of 8 also, will all come to be some natural numbers, and the sum of some natural numbers is also going to come to be a natural number, which has been assumed to be p. Next, now what we do is we further solve out the left hand side, which comes to 3 raised to the power 2n plus 2, right, minus 8n and minus 9 is equal to 64p. Obviously this is divisible by 64, right, and this children is what we had to prove, therefore we can say that this stands to be proved. So now I'll just quickly discuss the sum all over. Remember, this is a proof of the divisibility of a number, right, by 64 here, right, and remember, such type of sums have also been done by the principle of mathematical induction. This is the other method by means of which we can prove the divisibility of a number, right. So here we have 3 raised to the power 2n plus 2 minus 8n minus 9, which is to be shown to be divisible by 64. So here what we do is first we pick up the first number out of such a sort of expression, or the first term, right, that is 3 raised to the power 2n plus 2, and from that we try and bring 64 somehow, right. So this thus can be written as 3 raised to the power, taking 2 common from both of the terms of this binomial, we have 2 times of n plus 1. Then if we talk about this 3 raised to the power 2 times of n plus 1, we can write this as 3 raised to the power 2 whole raised to the power n plus 1, just like we have a raised to the power m into n, which can be written as a raised to the power m times of, or whole raised to the power n, right, which is the reverse of the rule of indices that we've learned. So using that, we are now going to convert this product in the form of whole power, right? Now children, 3 raised to the power 2 is 9, and further 9 can be written as 1 plus 8. So somehow we get to a power of 8 to be 64, which now we're going to use by expanding the binomial. Now when we have a binomial x plus a raised to the power n, then that becomes equal to nc0 x raised to the power n times of a raised to the power 0 plus nc1 x raised to the power n minus 1 times of a, and all of that continues up to ncn x raised to the power 0 times of a raised to the power n. So we apply this to the binomial at hand. That is, we have n plus 1 c0 1, that is x raised to the power the difference of the superfix and the suffix, that is n plus 1, times of 8, which is the second term raised to the power the number in the suffix, right? And to that we add now the second term, which is n plus 1 c1 times of 1 raised to the power the difference of the numbers in the superfix and the suffix. That becomes equal to n times of 8 raised to the power the number which is there in the suffix, and all of that continues, right? So in the second in the third term, we find that we are getting 8 squared, that is 64, right? So if we take the rest of the terms to the other side, all the other terms up to the last term is going to be a multiple of 64, because all of these terms will be having 8 square. So this is what has been done. Now children, here further what has been done is we now calculate the value of the first two terms, which comes to nc0, which is the first binomial coefficient, always 1 for any binomial theorem with a natural number power, multiplied with 1 raised to any power is always 1, and any number raised to the power 0 is 1. So the product of all of these three comes to 1. And then further we have the first binomial coefficient, which becomes equal to the superfix like I told you earlier. So we have this to be n plus 1 multiplied with 1 raised to the power n, that will become equal to 1, and further multiplied with 8 raised to the power 1, that is 8. Right, so this thus becomes equal to 8 times of n plus 1, and the next term onwards all has 64, that is 8 square. So we take this 8 square common from all of these, and thus the first term has none more, the second term has 1 more, and the third term has 2 more, and so on. If we talk about the last term, as it had 8 raised to the power n plus 1, 2 taken out, so now we have 8 raised to the power n plus 1, which is left. Remember, all the binomial coefficients are from the set of natural numbers. So we now have some natural numbers which are multiplied with natural numbers. Their products will also become natural numbers, and the sum of the natural numbers will also be natural numbers. So we consider the sum to be coming to be a number p, which again is from the set of natural numbers. So we have 64p on the other side, and on the left hand side we now had this 9 raised to the power n plus 1, which can be again brought back to 9, which can be written as 3 square. So now we have 3 raised to the power 2 whole raised to the power n plus 1, right? And further the first two terms subtracted, so we have minus 1 and minus 8 times of n plus 1. Now children, here we talk about multiplying this minus 8 to this binomial. So we have minus 8 minus 1, which will become equal to minus 9, and minus 8n is also there. So 3 raised to the power 2n plus 2 minus 8n minus 9 is equal to 64p, which thus can be shown to be divisible by 64. And children, this is what had to be proved, and thus stands to be proved. So is everybody clear about this? For sure? Mishra? Sure? Abdul? Okay, that's good, guys. Now make sure all of these sums are to be properly practiced. And remember that when you practice, only then when such sort of sums come in the examination, you'll be able to do them well, right? So bye children, have a nice time, and do practice all of these sums. Bye.